number one, which is definition of differentiation, and also a few techniques in differentiation that we have to use to solve a few questions based on the assignment that given to us. So, what is differentiation? Differentiation is an operation of mathematics that we use to find the derivative of a function. Derivative represent on how the quantity of changes responds to another quantity of changes, which is we call it as a fundamental operation in differential of calculus. So, what type of techniques of differentiation that we have to know so we can solve the question that given to us? Let me talk about that. First technique is chain rule. Chain rule is a function that are made by combining two or more functions. The formula that given is y equals to f prime gx, or we can say it as dy dx equals to f prime gx times g prime x. Second technique is product rule, which is a technique that we use to find the derivative of the product of two functions. The formula that is easier for us to use is u prime v plus v prime u. To differentiate two functions multiplied together, take the derivative of the first function and multiply it by the second. Then, add the first function multiplied by the derivative of the second. Next, quotient rule is used in calculus to differentiate a function that is the division of two functions. Replace the formula in form uv so we can get the formula which is dy dx equal vu prime minus uv prime over v squared. This rule only can apply when we have a function that have the division of two functions in it. The fourth one is implicit differentiation. This function is make use of the chain rule to differentiate a function which cannot be explicitly expressed in the form y equals fx yf. Here, I show you some tips or steps that we can do to apply this technique. As you can see, every term that have 1 in it, we must put a dy dx after we differentiate them. So, for the last answer, after we factorize all the terms, just left the dy dx on the left side to get the answer. The last one is linear approximation. The figure shows the formula that we have to use for this technique. Based on the formula, fx is the original function. Meanwhile, x naught is a point that approximating around. F prime x naught is a derivative evaluated at x naught, while the x is a point that we have round to the nearest number of x naught. We use the function when we want to estimate the value of a function near a point where we already know the value and derivative.
So this is part of question 2. For question 2a, question given is 3x squared second bracket x plus 2. As you can see, this is product rule. U equal to 3x squared and v equal to second bracket x plus 2. We differentiate u and it becomes 6x. We differentiate v and it becomes second bracket x plus 2 times 10 bracket x plus 2. We apply all this value in this formula and then it becomes this. We calculate it and then we factorize and the final result is second bracket x plus 2 times 6x plus 3x squared plus bracket x plus 2. This is the final result. So we move to question 2b. Question 2b, the question given is 4x plus 2 over cos x. As you can see, this is u over v. U over v is chain rule. So u is equal to 4x plus 2, v is cos x equal to cos x. We differentiate u and it becomes 4, differentiate v and it becomes negative sin x. So we just apply all the value in this formula. And then become this. And then we calculate it. The final result is 4 cos x plus bracket 4x plus 2 times sin x over cos x squared. Question 3, this is my calculation. So the question is 100x equal to x plus 1 times 2 minus second square for y times for dy dx equals 0. And then we just put this into the product rule, so we got this. And then we just calculate both of this, and then we got this. So we got this answer, y over x plus 1 to the x dy dx minus 2e power to the x plus 1 minus cos second square for y dy dx equals 0. So we arrange the dy dx to the left side and the other to the right side. After that, we factorize the dy dx. So we got this. And then because we want the x to be alone, so we left them to the left side, and we bring this to the right side. So we got 2 equal to x plus 1 minus y over x, and then we over 1x minus 4 second square for y. And then for the best answer, we just times them with x. So we got 2x equal to power to the 2x plus 1 minus y over x open bracket 1x minus 4 second square for y, and then close the bracket. So this is the final answer.
To solve question number 4, we need to use linear approximation formula. This is the formula. Then find x, x naught, and delta x. X equal to 80.99. X is decimal number we get from the question. X naught is round off the x number. Delta x is x minus x naught. So x is smaller than x naught. So the answer is negative 0.01. Then find fx. Find fx. Fx is sec for x minus 2 over sec x. Then differentiate this to find f prime x. F prime x is 1 over 4 sec 4 x cubed minus 1 over sec x cubed. Then substitute the value or apply the formula and substitute the value of x, x naught, and delta x. Then calculate this. Don't forget the bracket, and the final answer is 2.778. Don't forget, we need to write it in 3 decimal number as the question given. That's all from me. The techniques of differentiation in calculus are fundamental tools that allow us to understand and analyze the behavior of functions. Methods such as the power rule, product rule, quotient rule, chain rule, and implicit differentiation enable us to find the rate of change of a function in a wide variety of contexts. Mastery of these techniques is essential for solving real-world problems in physics, engineering, economics, and other fields. Overall, differentiation is a powerful and versatile mathematical process that forms the backbone of much of modern science and technology.